Did you know taking your dog outside to play can help you understand calculus? Well, that's what we're talking about today in this video from High Peak Education. What's going on, everybody? Hope you're having a wonderful day. And in fact, today we'll be discussing a Calculus 1 application problem where a puppy, and who doesn't like puppies, right? A puppy is moving away from an owner and towards an owner, and that will be a physics, one-dimensional kinematics application problem that'll help us understand calculus better. So stay tuned until the end of the video because we will discuss why it's important to think about signs, that is positive or negative, out there in the real world, and that can help you to be successful in thinking about mathematics and thinking about problems. So let's go ahead and get into today's video. So it says a puppy playing fetch runs back and forth along a straight path to and from its owner. Initially, the puppy is right next to its owner. The velocity of the puppy is graphed below. So that's v of t versus t. Okay? So it looks like we've got it over 20 seconds, and we've got, looks like, region A and B. Number 11 says, on which time interval or intervals is the puppy slowing down? 12, at which time or times is the puppy farthest from its owner? 13, after exactly 20 seconds, the puppy returns to its owner. Okay? What can you say about the shaded areas A and B? First question is, what do you note about the V versus T graph? What's actually being plotted here? Yeah, the velocity versus time. So what we're showing there is not position versus time, which you and I in kind of the introduction were discussing a little bit. What's actually being shown is velocity versus time, okay? So in other words, how fast. So I want to ask you, at which point is the puppy moving fastest? About how many seconds? Yeah, 6 seconds. In other words, that's just basically the vertical axis value of the velocity is largest there. Exactly. So that's when the puppy is moving fastest, okay? So let's go on to the first question, number 11. At which time interval or intervals is the puppy slowing down? If the puppy's slowing down, what's happening to the velocity? When the puppy is slowing down, what that means is if the velocity is in one direction, the what is in the other direction. Yes, the acceleration is in the other direction. Let's say the puppy is moving to the right. So imagine that if the puppy is moving away from the owner, we could imagine there could be some, x-axis here, right, to the right. So if the puppy is moving away from the owner, that's in the positive x direction. Is that going to be during region A or region B if the puppy's moving away from the owner? A, right, because the velocities are positive, right? When the velocity is positive, the puppy's moving this way. This is a positive velocity, moving to the right. Whereas moving to the left is just region B. If the velocity is positive, but the acceleration is negative, the puppy is slowing down. Look at between 0 and about 6 seconds. What's happening to the velocity? Increasing or decreasing? All right, it's increasing. But now let's look between 6 and 8 seconds. The puppy is still moving to the right, but what's happening to the size or the magnitude of the velocity? Right, it's decreasing. So would we say between 6 and 8 seconds, perhaps, the puppy is slowing down? If the puppy is moving to the right, the velocity is positive. If the acceleration is negative, that means the velocity itself is decreasing. So in other words, you're still moving to the right, but you're slowing down. In other words, like the speed, which is how fast, is getting less. Okay? So you're slowing down. Another way to interpret it using the graph is, what do you note about the slope here throughout this time period? Yeah, the slope is negative. Now, just because the slope is negative does not mean we're always slowing down. If the slope is negative, it means the acceleration is negative, because acceleration is the change in velocity with respect to time. In calculus speak, A is equal to the change in velocity with respect to time. That's dv dt. Notice that the slope is also negative, say, down here, between 8 and 12 seconds. But even though the slope is negative between 8 and 12 seconds, is the puppy slowing down or speeding up during that period of time? First of all, let me ask you this. Is the velocity positive or negative in region B? Yeah, the velocity is negative. So we know that everywhere between 8 and 20 seconds, the puppy is moving left. Like the entire time the puppy is moving left. If the acceleration is negative and the velocity is negative, we're speeding up in which direction? Yeah, the leftward in the negative direction. Correct. Just because the slope is negative doesn't necessarily mean we're slowing down. But just like you said, whenever the acceleration and the velocity have opposite signs, S-I-G-N-S, then we're going to be slowing down. And that's a time interval. Is there another time interval? Let's look at region B. Region B, the puppy is always moving to the left. That's negative velocity. But how about the acceleration? Does it ever go opposite sign? So from 12 to 20, we would also be slowing down. B. Yeah, I think so. Let's have a look at 12. At what time or times is the puppy farthest from its owner? When the puppy is farthest from its owner, what would that actually look like on an x-axis? What's the largest position that the puppy is away from the owner? So in other words, what's the largest magnitude x value that the puppy achieves moving away from the owner? During period A, the puppy is always moving to the right. During period B, the puppy is always moving back to the left. So the question is, at what point does the puppy stop moving away from the owner and start moving back towards the owner? Just intuitively. Yeah, at 8 seconds. So the answer is going to be 8 seconds. Now, by the way, that's more of a physics argument that you and I just made, but let's see if we can merge it with the calculus argument. The calculus argument is the following. You would accumulate on a position versus time graph. So if we graphed here position versus time, so x versus t, you would accumulate the highest value at 8 seconds. Now, why is that? Because it turns out that the position function, x of t, is what calculus operation starting with the velocity function. Yeah, I'm saying the position function is what calculus operation related to the velocity function. You take the position and you take the time derivative, you get the velocity. But I'm saying if we start with the velocity, because that's what we have to start with, right? We have the velocity to sort of start with. If we start with the velocity and we want to know about the position, what operation using calculus must be performed to go backwards from a time derivative? So in other words, I'm talking about the definite integral. Right. Yeah. So the definite integral of v of t dt is going to give us the position function. Suppose you wanted to know how much did the position, say, change from 0 to 8 seconds. You would take the definite integral from 0 to 8 seconds. And notice that's all going to be positive area. Do you see what I mean by positive area? It's above that time axis. So since it's above the time axis, it achieves its maximum x position at 8 seconds. But then after that, it starts moving back towards the owner, right? So this is obviously not some perfect x versus t graph, but you get the idea. The calculus argument is that we continue to accumulate positive area under the curve, which is the geometric interpretation of the definite integral. We accumulate that positive area up until 8 seconds, but then we start accumulating negative area. Negative area, we might do dots here as opposed to lines, right? Because it's the opposite sign, S-I-G-N. It's moving left as opposed to the right. A Riemann sum is only possible when you have some interval that you know, and then furthermore, you have to be able to split the interval up, and then you'd also have to know something about things on the vertical axis. So whenever you're given a graph sketch here, you should be able to come up with the answer just based upon, I don't know, let's just say intuition only, but you should be able to come up with it based upon the principles of what the graph shows. In principle, area A is only positive. In principle, area B is only negative. Yeah, good question. I read ahead to number 13 because it does say the shaded areas A and B are meant to be equal size, okay? So that's not necessarily obvious if I didn't read ahead to number 13. Getting back to your other question, region B does not look significantly different than region A, at least to my eyeball. It doesn't look substantially larger, like 2 or 3 times larger. So the reason I bring this up is because notice that a bunch of region B is going to cancel out region A as it relates to how far the dog is away from the owner. In other words, even if, let's say, region B is larger than region A, a bunch of that period of time where the dog runs back might bring the dog back to the owner, and then the dog might run past the owner back to the left, just a little bit, but probably not too much. So it's just likely from what we were just discussing that 8 seconds is the furthest away because the dog was moving away from the owner the entire time between 0 and 8 seconds. Right. Yes. In fact, they do even say that. I think somewhere they said initially the puppy is right next to its owner. Now that's just code for if the puppy starts next to the owner, x equals 0 is the origin, is where the puppy starts. So number 13, it says, after exactly 20 seconds, the puppy returns to its owner. What can you say about the shaded areas A and B? Well, first of all, are A and B going to be the same sign, S-I-G-N? No, so one's positive and one's negative. And we already kind of discussed that. But it turns out if we compare absolute values, like in other words, if we compare magnitudes of each areas, we might be able to say something about, suppose the puppy goes 28 meters away from the owner. That means if the puppy returns to the owner, that means the area of region A is 28 meters, but then the area of region B would also be, say, 28 meters, right? Because we have to come back. So the two areas should be the same, but if the two areas should be the same, then which of those does that indicate on number 13? B. I think so. So I think in choice B here, if we do absolute value of each area, then they should be equal because the puppy returns. So hopefully now you have insight and understanding as to why when you take your dog outside and your dog is running away or back towards you, especially if it's a really wonderful puppy, you can understand calculus. You can understand positive and negative away from you and back towards you. You can understand slope. You can understand area. In other words, you can understand derivatives. You can understand integrals. If you plot, let's say, velocity versus time, and you can think about how you can form a position versus time graph from that and understand how the motion goes. So this is a really nice application problem of calculus and physics. And I hope that you learned a lot today, and I hope that when you get around things the rest of your day, think about defining axes, to think about defining the positive direction, the negative direction. Think about how you can understand motion. So this is really important as it relates to really understanding and setting up problems and describing our world. So thank you for watching High Peak Education. Please smash that like button if you enjoy this content, and ring that notification bell. Subscribe to the channel to never miss another video. And please share these videos amongst your social media networks. Social media links will be down in the description. Please leave a comment, and I look forward to reading your comments. Tell us in the comments how you're going to use this information in your daily life, or even just in your calculus class or physics class. I will see you in the next video.